So mainly system of linear equation in three variables x, y, z. Okay, so you should be concentrate on that. Fine. So what is the procedure to find the solution of system? So given system of equation, we can change it to matrix form, that is Ax is equal to B. So what is the name of A? A is called coefficient matrix, X is called variable matrix, and B is called column matrix. Okay, column matrix, right? Fine. So let us do one more question in the system of equations. Right? Yeah. Exercise 4.6. See, question number 15. Let's do question number 15. So here question number 15 is they given capital A. So capital A is equal to 2 minus 3, 5. Okay. If capital A is equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. Okay. 1, 1 minus 2. Find A inverse. First we need to find A inverse. Then using A inverse, solve the system of equations. Solve the system of equation. The given system of equations are 2x minus 3y plus 5z is equal to 11. 3x plus 2y minus 4z is equal to minus 5. X plus y minus 2z is equal to minus 3. Okay, so here first we need to find A inverse by using A. After that, we have to find the solution of given system by using this A inverse. Okay, since we know that A inverse A inverse is equal to the formula is 1 by determinant of A, that A into adjoint of A. Am I right? So first you should find det A. Det A. If det A is not equal to 0, then only the inverse is existent. You should check. So no need to find first adjoint of A. Okay. In case if you find adjoint of A, after finding adjoint of A, if you find the det A becomes 0. So no need to, no use for finding adjoint of A, right? So first you should find det A, that we know very well how to find the determinant of a matrix. So I want to use the first row. I want to use first row, then I want to find the determinant. I said very clearly, there are 6 ways to find the determinant of 3 by 3. 6 ways. If it is 4 by 4, 4 by 4, 8 ways are there. 4 plus 4, 8. If it is 5 by 5, 10 ways are there to find the determinant. Right. Now, plus 2. Determinant of A is equal to plus 2 times of, yeah, determinant of sub square matrix after deleting the first row and first column. 2 minus 4, 1 minus 2. Then after minus it to minus, it will be plus 3, and then delete this first row and second column. The remaining elements are 3 minus 4 and 1 minus 2, right? Then plus into 5 plus 5 times of determinant of, so eliminate or delete the first two and third column, then 3, 2, 1, 1, right? So clearly this is equal to determinant of A is equal to, so 2 times of AD minus BC, right? Here minus 4 minus into minus plus 4. Fine. Then next plus 3 times of, so here it is minus 6 plus 4. Then plus 5 times of 3 minus 2. So this is clearly equal to, here it is 0. Here minus 2, remaining minus 2 into 3 minus 6, minus 2 into 3 minus 6, and here 5 into 1 5 plus 5. So this is equal to minus 1. So this is determinant of a data value should not equal to 0 here. So what about the given matrix? So given matrix is called non-singular matrix. Therefore, we can say A is called non-singular, then A inverse is exist. Therefore, A is non-singular matrix, non-singular matrix, and A inverse is exist. So A inverse is exist, then we can find adjoint of A, right? So how to find adjoint of A? Yes or no? So first find a minus of the matrix, then cofactor, then adjoint of A is the transpose of cofactor matrix. So first given matrix is 2 minus 3 5 3 2 minus 4 1 1 minus 2. Everyone you can find minus, all of you find minus, and all of you find cofactors. Then find adjoint of A. Adjoint of A is equal to C power T. What is adjoint of a matrix? Yes, do yourself, because we solved many problems. Like we found many times minus. Minus nothing but I want to find minus of this 2. 2 nothing but 2 is belongs to first row and first column. Delete first row and first column, determined. Already we found here by using whatever the values you get here. These are the minus. 0, minus 2 and 1. 0, this is 0, minus 2 and 1. So these are the minors. 0, minus 2, 1. Then we have to find the minors of second row. 3 is belongs to second row, first column, delete this, then minus 3 5 1 minus 2, determinant of this 2 by 2 square sub matrix. So 6 minus 5, that is 1. Next, so minor of this 2 means eliminate second row, second column. 2 5 1, 2 into minus 2 minus 4 minus 5, this is minus 9. And the next minus 4 is second row and third column. 2 minus 2 into 1, 2 plus 3 5. Then here 1 nothing but, so 12 minus 10, that is 2. Then 1 is belongs to third row, second column. 2 into minus 4 minus 8 minus 15 minus 23. Okay, then at last minus 2. So minus 2 is belongs to third row, third column. 2 to the 4 plus 9. 4 plus 9. 4 plus 9, it is 13. Is that right, everyone?
So then again multiplication.
Yes,
Sir, multiply by minus 2 will come also.
I didn't get you. Is here all minors are correct or not? Any one of the value is wrong?
Right.
So anything is wrong, you can inform to me, right? Okay. So after that, we know very well. So there is a formula to find cofactors. Cij is equal to minus 1 whole to the power of I plus j into mij. Nothing but what to do. If you apply this condition, we are going to get here like plus minus plus. Okay, yeah. So here it is plus minus plus minus plus minus plus minus plus. Okay, now minus 1 and minus 1 minus 9 and minus 5 and 2 here 23 and 13. Is that right? Okay. Now adjoint. So adjoint of A is the transpose of the cofactor matrix. Now you can interchange. You can interchange rows and columns. So we are going to get like 0 to 1. So 0 to 1 becomes first column. The second row becomes second column. Minus 1, minus 9, minus 5, and 2, 23, 13. Okay, that is adjoint of A. Okay, finally, A inverse is equal to 1 by det A into adjoint of A. Substitute both the values in equation 1, condition 1. So, therefore, A inverse is equal to 1 by det A, 1 by minus 1 into adjoint of A. Adjoint of A, just write those values. So 0, minus 1, 2, and 2 minus 9, 23, 1 minus 5, 13. Am I right? Now just multiply with minus 1. Multiply with minus 1 to each and every element. So finally we are going to get, so this is equal to, okay, this is equal to, then 0 becomes 0, 0, 1 minus 2 and minus 2 9 minus 23 and minus 1 5 minus 13. Okay, this is A inverse. Once you check the A inverse whether it is correct or not. If A inverse is correct, then only we are going to get the solution also correct. If A inverse is wrong, solution becomes wrong. So all of you check, just book back answer. Yes, students.
Correct.
Okay, if it is correct, we can proceed. So how can you find by using this A inverse, then x, y, z value? Solve the system of equation in the sense we need to find x, y, z values. Okay, we have to find x, y, z values. Okay, so note it down up here. You have to practice more number of problems which is related to inverse of a matrix, right? Right. So now we can go through the procedure. First given system of equation, we can change it to matrix form. Okay. That is Ax is equal to B. After that, X is equal to A inverse into B. Right. So the system is in matrix form is, so matrix form is Ax is equal to B. Ax is equal to B. Right. Now, if we write in matrix form, then look at here, what are the coefficient here? 2 minus 3, 5, 2 minus 3, 5, and 3, 2, minus 4, and the last one is 1, 1, minus 2. Okay, these are the coefficient of x, y, z. So that x, y, z we have to write as column matrix. Then right side is what are that 11 minus 5 minus 3, right? Okay, from this condition, which implies, shall I write capital X is equal to, if I take A is right side, A inverse into B. Yesterday already we proved this. Am I right? So X is equal to always A inverse into B. A inverse into B. Fine. So look at here. What is A here? What about A? Is A coefficient matrix is equal to the given matrix or not? If we comparing this with this matrix form with Ax is equal to B, this is A, this is X, this is B. Okay, so after comparing this, you should write where A is equal to this coefficient matrix, X is equal to X, Y, Z, and B is equal to 11, minus 5, and minus 3. Okay, so after writing all the matrix, then you can write X is equal to A inverse B. Okay, so now clearly this both the matrices are same. Both the matrices are same, and already we found A inverse. A inverse. Again, no need to find inverse of given matrix because both matrices are same. So this A inverse we can substitute here, this B matrix substitute here, just to multiply both the matrices, then we'll get X value directly. Okay. So now I'm going to substitute all the values here. X, Y, Z is clearly equal to A inverse. A inverse value is already we found that is 0, 1, minus 2, minus 2, 9, minus 23, minus 1, 5, minus 13 into B matrix, that is 11, minus 5, minus 3, right? So all of you multiply this, both the matrices, because here the matrix of order 3 by 3, 3 by 1. So easier matrix multiplication is possible or not? Yes, possible. So here 3 is equal to 3, then the resulting of order 3 by 1. We are going to get 3 rows and 1 column. Nothing but column matrix will get. So this is clearly equal to, yeah, what about this? 3 by 1 resulting 0 into 11, 0 minus 5, 0 minus 5 plus 6, and next second first row column, second row column, like 2 minus minus 22, and 9 into minus 45, and this clearly 66. Is it right? Sorry, 69. Okay, fine. So now minus 11, then minus 25 plus 39. Is that right? Now, this is clearly equal to x, y, z. The right side values are 1. So what about that?
1, 2,
67. 2 here,
3.
3. So when you comparing both the matrices, because here order is same, 3 by 1, 3 by 1, then we can equating the corresponding values. Then we are going to get x value is 1, and y value is 2, and z value is 3. This is the required solution of given system. In case if you get any doubts, just substitute x, y, z value in given system, whether the given equations are satisfied or not, like that. Okay. Getting any doubts, you can ask. So coming to evening classes, Molalis are having some other work. Okay, that remaining concept like ellipse and hyperbola and parabola also I'm going to explain you. Right? I will inform you the time. The time we will discuss. Yeah, okay, students, let us do the last question. So, last question is very, very easy. They given word problem. Okay. So, is it difficult? No, not at all. So, given word problem, we can convert it into equations. First, given problem, we can convert it into system of equation. After that, that system of equation, we can change it to matrix form. Then after, we can go to the procedure, right? Okay. Let's see here. What about the last question here? The cost of, look at here, the cost of 4 kg onion, 3 kg wheat, and 2 kg rice is rupees 60. And the cost of 2 kg onions, 4 kg wheat, and 6 kg rice is 90. At the same time, the cost of 6 kg onion, 2 kg wheat, and 3 kg rice is 70. Find the cost of each item for kg by matrix method. Okay. So if we consider for each kg of onion for 1 kg, we can consider rupees x rupees. Okay, and in the same way, wheat for kg, we can consider y rupees, and in the same way, the last one is rice. Rice for kg, we can consider as z rupees. Okay, z rupees. So is it difficult to write the system of equation? No, not at all. So it's very easy to write the system of equations, right? So how many kgs of onion here? The cost of 4 kg onion. 4 kg means 4x plus 3 kg is that 3y plus how many kgs of rice? 2 kgs of rice, 2z. So total price is 60 rupees. Next, in the same way, 2x plus 4y plus 6z is clearly equal to 90. And next, 6x plus 2y plus 3z is equal to 70. Right? 4, 6, 2, 4, 6, and 4, 3, 2. Right. So I converted into system of equations. So 4 kgs of onion, 3 kgs of right wheat, and 2 kgs of rice is clearly equal to 60 rupees. Okay. In the same way, you have to write remaining two conditions. Okay, these are the system of equation. See here, the second equation, even we can take two common you can cancel on both sides. Then the second equation becomes x plus 2y plus 3z is equal to, we can write 45 also. 45 also correct. Okay. So otherwise you can do directly. Even you can do directly also. So first we can change it to matrix form. What is the matrix form here? Like ax is equal to b, then 4 3 2 and 2 4 6 6 2 3 into x y z, so is equal to b matrix, that is 60 90 70, right? So comparing, you will get a value, after that find dta, then after that find adjoint of a, then after that you can find inverse, then finally x is equal to, from this equation x can be written as a inverse into b. This is the homework you can do at home, right? So now let us discuss the objective questions which is related to the system of equation. Objective questions, okay. And Ncert students also observe here. Yesterday, clearly we discussed about homogeneous, non-homogeneous. So very simple. Here we are expressing the matrix form is Ax is equal to B. Ax is equal to B. So here B is equal to 0. B is equal to 0 means the system of equation becomes Ax is equal to 0, nothing but not 0, it is 0 matrix, null matrix. So ax b value is 0, the case 1. When b value is equal to 0 means right side, then ax is equal to 0 matrix. So then this equation is called homogeneous system of equations, right? Then here case 2, b value should not equal 0. Example, these are the example. If you see right side, all values are non-zero values, 60 90 70. So when x is equal to b, this system is called non-homogeneous system of linear equations, even linear equations, SLE. Okay, because all degrees are same, equal to 1, x power 1, y power 1, z power 1. So when degree is 1, we can say that linear equation. So these are the linear equations in xyz, right? So system of linear equation. So here clearly I told you, this is in this case ax is equal to b. So when ax is equal to b, then b value is 0. This is called homogeneous. For homogeneous system of linear equation, there are two solution. I said very clearly, trivial solution. Trivial solution, nothing but, so if I take like a 3 by 3 matrix, 3 by 3 matrix, x is equal to y is equal to z is equal to 0. When x y z all values are 0, see all are, for example, if I take here 0, like 0 0 0, now here x is equal to 0, y is equal to 0, z is equal to 0, one of the solution. Then how can you say that the system having a trivial trivial solution without solving? Can you say that it has a trivial solution? Yeah, exactly. When determinant is not equal to 0, so after converting into matrix form, find the det value is not equal to 0, you can say directly the system having only trivial solution. Only trivial solution. What is the trivial solution? 0 0 0. Then when the homogeneous system of linear equation having non-trivial solution, non-trivial solution, nothing but simply remember that determinant of a is equal to 0, then system having non-trivial solution. In case any objective point of view and competitive exams, they'll ask just whether the system having a trivial or non-trivial. In case in the question, if they mention the given system having uh, system having a non-trivial solution, then find the value of key. find the value of lambda, find the value of u. They'll ask some constant. Non-trivial means given determinant equating to 0, and trivial means not equal to 0. Okay, just we have to remember these two values. Very important. Many questions they'll ask already. Okay, so this is which is related to homogeneous. Homogeneous. So coming to non-homogeneous, clearly we discussed that. So coming to non-homogeneous. Okay, so in that non-homogeneous, when you observe, like right side b value is not equal to 0. Am I right? Non-homogeneous b value is not equal to 0. Okay. So ax is equal to b not equal to 0. In that case, three types of solution. One is a unique solution, one is a no solution. Then another one is infinite solution. Okay, study already we discussed. Let us see a few the questions which are related to the system of equation class work 2. All NCERT student, you must practice all the questions. Even try to practice miscellaneous. Okay. Yeah. Page number 112. Page number 112. Yesterday we completed the questions which is related to inverse of a matrix. Okay, solution of simultaneous equations. Equations. Okay, first let us see the question number 49. Then we'll go for question number 48. Question number 49, the number of values of k for which the system of equations, they given the equation in terms of x and y. Okay, x and y, and clearly the given has no solution. As no solution is. So for what value of k the system has no solution. You're not required to change the matrix form. So they given clearly in terms of x and y alone. When they given in terms of x and y, we know very well if the system is a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2. Then since we know that these two equation having no solution, then a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Is it clear? So in that case the system has no solution. Okay, so even your given system you can comparing with these two equations. So your a1 value a1, so what is a1? I am writing directly here. A1 is k plus 1 by a2 is k is clearly equal to uh, b1 value is 8 by b2 k plus 3 not equal to c1 by c1 is 4k by 3k minus 1. Okay, right. So I substituted directly here. Then what are the options they given? The first option is um, 1, second option 2, third option 3, fourth option is infinite number of key values. Okay, so simple, you can equating these two, first two, cross multiply your k plus 1 into k plus 3. Okay, for what value of k both will be equal, just option verification. Substitute k is equal to 1. Are you going to get uh, this value equal to this?
Yes, sir.
Yeah, k is equal to 2 then. Okay, k is equal to 1, it satisfies, right? 2 by 1 is 2, 8 by 4 is 2. LHS equal to RHS. Then when k is equal to 2, not satisfied. 3 by 2 here, not like that. So k is equal to 3 also. 4 by 3, it is not 4 by 3. So k is equal to 1 is the only option satisfying this condition. So first option is right. Okay, that's it. And next question, question number
Sir,
50. Yes.
if you substitute k as 1, it will be coming 4k by 3k minus 1 is 2, no, sir.
4k.
By 3k minus 1, that value also become 2, no, sir.
Here, this value.
Yes, sir. If you substitute k equal to 1, then
Yeah,
all
actually, if you use this condition, if you equating to any one of this value, k should not equal. K should be not equal to, but they are asking k value.
if you equal to get 2 equal to 2 not equal to 2, sir.
2. Once again, can you repeat?
Sir, the value of 4k by 3k minus 1 is also 2, sir. We
When for
substitute
what value of k? K is equal to 1.
yes, sir.
Okay, let us see here. Oh, so when we substitute k is equal to 1, so even though it is 4 by 2, we are getting again 2. For other values, 8 by 5. Okay, let's see the condition, whether I have given
We
correct
can
condition
substitute
or
k
not.
as 3, no, sir.
It should be not equal actually.
We can substitute k as 3, sir.
Okay, when k as 3 is here, these two are equal. K as 3 means 4 by 3. Okay, sorry, sir. Right, right. Right, 4 by 3. 8 by 6 means, okay, 4 by 3. When you substitute here, 3 here, 8 by 5. Oh, right. So I thought that it is satisfied by only k is equal to 1. So actually, what is the answer? K is equal to 3. When k is equal to 3, here these two are equal and it should be not equal. So, but k is equal to 1, if you observe this last one, all three are equal, nothing but infinite solution. When a1 by a2 equal to b1 by 2 is equal to c1 by c2, then in that case, the system having infinite solution. Okay, they are asking here clearly, no solution. It must be not equal, right? So option number 3. 3 is the correct answer. Very good. Next. Question number question
Sir,
number 50. Yes.
the breaks